What is OOP? Object-Oriented Programming, or OOP for short, is a programming approach that relies on the concept of classes and objects. It is used to structure a software program into simple reusable pieces of code that are usually called classes. These classes define the structure and behavior of things, and you use them to make specific examples called objects. Why it is important? Object-oriented programming offers several important advantages, making it an essential approach for building organized, reusable, and scalable software systems. First, OOP promotes modularity. By organizing code into separate classes, each handling a specific task, this makes programs easier to manage, test, and debug. Second, it supports reusability. Existing classes can be extended using inheritance, allowing developers to build new features without rewriting code. Third, OOP ensures encapsulation, which keeps data secure by controlling how it's accessed and used. This helps prevent errors and improve security. In short, OOP is important because it helps developers build software that is clean, easy to manage, and adaptable that are essential in today's rapidly advancing field of technology. Here's an example of a real-world comparison that shows the purpose of object-oriented programming. A smart home system. Imagine you have a smart home with different devices, like lights, aircon, speakers, and a coffee machine. Each device is like an object. You don't control wires, you just tap, turn on in the app. Each device knows how to respond. In OOP, each object knows how to handle its own task.
Now that you know basic knowledge about OOP, you might be wondering what is its difference with procedural programming. Procedural programming and object-oriented programming are two different ways of writing and organizing code. Procedural programming focuses on functions and steps which carries out each step systematically in order, so that a computer can easily understand what to do. While OOP focuses on objects or things. Let's think of it as this example. You make a class about cars. From the car class, you could create objects like color and model. When it comes to security, procedural programming does not offer any method of hiding data. On the other hand, we have abstraction and encapsulation in OOP that made it possible. In addition, the data and functions in POP are separated, while in OOP, data and functions are combined in objects. Lastly, it is harder for programmers to reuse code in POP in comparison to OOP. For better understanding, we have here an example of procedural programming. Notice how it has linear flow. It displays menu, gets user input, calculate total, and displays the result. The logic is written inside the main method, and there's no reusable components or separate method to handle tasks like the input, calculation, or output. You can also see that we cannot reuse the logic for multiple orders. While here in OOP, we have applied the concepts of encapsulation as we have fields marked as private which cannot be accessed directly from outside of the class. Not just that, but we can also add multiple objects such as order, each with its own unique data. This also promotes modularity and reusability, since the order class can be reused to create as many orders as needed. Plus, the logic for displaying and calculating totals is built into the class, so you don't have to repeat it elsewhere. Now, here are the key features of advantages of object-oriented programming over procedural programming. First, it is faster and easier. It has clear structure and you do not have to repeat yourself every single time because it promotes code reusability. Lastly, it has a lot of concepts we can use to hide and inherit data, which you can learn by the end of this video.
Let us begin with encapsulation. It means wrapping data and methods into a single unit, or a class. It hides internal details using private variables and uses getters and setters to access and modify those variables. What we want to do is use private for sensitive data and provide public getters and setters. And what we don't want to do is to expose those variables directly by using public modifiers. Our second concept of object-oriented programming is inheritance. It allows a class, called subclass, to reuse the fields and methods of another class, called superclass. It's a way of one class to inherit or take properties and behavior from another class using the extends keyword. We use inheritance because of its code reusability, organization, and enabling our next concept, which is polymorphism. Our last concept is polymorphism. It means one method behaves differently based on the object that calls it. What we do in polymorphism is override methods. Overriding methods can only happen when there is inheritance at play. It happens when the child class implements something different from the method inherited from the parent class.